Welcome to The Explainer. Today, we're digging into the secret language that lets AI actually talk to the real world. We're going to explore this quest to build a universal connector for AI agents and why it's really the key to unlocking what they can truly do. It's a strange question, isn't it? You've got an AI that can pass one of the hardest professional exams on the planet, but ask it a simple question like, hey, what's the weather like right now? And it just can't. The answer to this little paradox actually reveals a huge limitation in even the most powerful AI models, and it really sets the stage for everything we're about to talk about. All right, so to really get this, we have to start with what an AI model is, all by itself. The best way to think about it is like a brilliant brain, but it's a brain that's stuck inside a jar, completely cut off from the world. So without any way to connect to the outside, that model is basically trapped in time. It can only generate answers based on the massive but totally static data it was trained on. It knows a ton about weather patterns from a year ago, sure, but it has absolutely no idea if it's raining outside your window this very second. It can't get new data, and it definitely can't do anything in the real world. So, how do we get this brain out of the jar? Well, that's where tools come in. A tool is just a function that the AI can use to reach out and interact with the world. Think of them like the apps on your smartphone. They become the AI's eyes and hands, letting it see new things and actually take action. Okay, so let's walk through it. When you ask for the weather, here's what's happening. The AI looks at your question and realizes, hey, I don't know this. I need real-time data. So it calls up a specific weather tool. That tool grabs the current forecast, sends it back, and then the AI uses that fresh info to give you an accurate answer. It's a simple little dance, but it's how the AI bridges that gap between its brain and the real world. So tools are amazing, right? Problem solved. Well, not quite. Because as soon as thousands of developers started creating thousands of different tools, we ran into a whole new kind of chaos. How in the world do you connect all of them? And this chaos, it actually has a name, the N by M integration problem. It sounds super technical, I know, but it perfectly describes the nightmare of trying to hook up every AI model to every single tool out there. And honestly, it's the challenge that threatened to grind AI innovation to a halt. Just picture this. You've got a box full of all your favorite gadgets. Now imagine that for every single one, you needed a completely different, custom-built adapter to plug it into the wall. That's the N times M problem in a nutshell. Every new AI model needed a custom connector for every single tool. It was a mess, slow, incredibly expensive, and it just couldn't scale. Okay, so this wild west of connections clearly wasn't working. To fix it, the industry needed to agree on something. It needed a standard, a universal language that any model and any tool could speak. And that solution is an open standard called the Model Context Protocol, or MCP. Honestly, the easiest way to wrap your head around it is to just think of it as USB-C for the AI world, one standard plug to connect everything to everything. So the official definition is that MCP is an open standard that creates this universal plug-and-play interface. It basically lays out all the rules, from the exact format a tool needs to describe itself in, all the way to how the API calls work, so that any tool can connect to any model, no custom work required. And man, this slide just shows you the difference so clearly. Before, you had all this brittle, custom code for every single connection. Now it's a plug-and-play standard. Development goes from being slow and expensive to rapid and reusable. The whole ecosystem shifts from being this fragmented mess into something modular and unified. So MCP sounds fantastic in theory, right? Like the perfect solution. But what does this new standard actually promise in the real world? And more importantly, are there any hidden challenges that come along for the ride? Now, this chart is super interesting because it shows us what people are actually using MCP for. And look at that. Support for standardizing tools is at 99%. It's basically universal. But the other features the protocol defines, way lower adoption. This tells us the entire ecosystem is laser-focused on solving that one core connection problem first. The promise of getting this right is just huge. Development gets way faster, you get a whole marketplace of reusable tools popping up that people can share, and maybe the coolest part is that AI agents can start to discover and learn how to use new tools all on their own, making them way more autonomous and capable. But of course, with all this new power comes a pretty critical performance bottleneck we have to talk about. It's called context window bloat. And you can think of it as the hidden cost of giving an AI all these new superpowers. So here's the catch. For an AI to even know what tools it can use, the instruction manual for every single tool has to be stuffed into its prompt. This chews up what's called the context window. It's like the AI's short-term memory. If you overload it, the model gets slower, it costs more to run, and its reasoning can actually start to get a little fuzzy. This creates this really tough trade-off between capability and performance. But performance isn't the only challenge here. As we give AI more tools and connect them to the real world using a standard protocol, well, we open up a whole new can of worms when it comes to security risks. There's this classic security vulnerability. It's been around for ages, called the confused deputy problem, and it is finding a dangerous new life in the world of AI agents. It's basically when a program with a lot of power is tricked into misusing its authority. And with AI, the potential for that is bigger than ever. Let me paint you a picture of a little heist. An AI assistant is connected to a company's secure code repository through one of these MCP servers. Now, a hacker crafts a really sneaky prompt, tricking the AI into accessing a secret file and sharing it. The AI, just trying to be helpful, gets confused and tells the powerful MCP server, the deputy, to do it. The server obeys, and just like that, the company's secrets are leaked. This means securing everything requires a multi-layered defense. This table shows some of the key risks and how you fight them. We're talking about things like enforcing a strict allow list of approved tools, sanitizing all your inputs and outputs to prevent prompt injection, and, this one's so important, using the principle of least privilege. So no single part of the system has more power than it absolutely needs. So here's the crucial point to take away from all this. MCP is just the protocol. It's the universal plug. But it does not come with a built-in surge protector. It enables the connection, but it doesn't inherently provide protection. That responsibility falls 100% on the enterprise that's building the system. And that really brings us to the central question we have to answer to safely unlock this future of AI. As we give these agents more and more power to act in the world, the most important work won't just be about making them smarter, but making them safer. How do we build the right guardrails to make sure they become our trusted partners and never our confused deputies? The answer to that question is going to define our entire relationship with artificial intelligence.